Good day to all. Today we are going to see about that electrical braking. Before we're going to see what is that electrical braking and what is the purpose of electrical braking. The process of applying a braking can be termed as a braking. The process of applying a brakes can be termed as a braking. Now coming to the term or question what is braking. Simply we can classify the term braking into two parts. First one is mechanical braking, then electrical braking. The mechanical braking is left out here because as it is on electrical engineering, we should only focus on that electrical braking here. See, in mechanical braking, the speed of the machine is reduced slowly by mechanical process, but electrical braking is far more interesting than that because the whole process is dependent upon that flux and torque directions. Because of this flux and torque direction only the braking will takes place. Then we will further see through the various types of braking, but the main idea behind each type of braking is the reversal of the direction of the flux. It is the process of reducing speed of any rotating machine. Now the brakes are used to reduce or change the speed of the motor. We know that there are various type of motors available, which is a DC motor, induction motor, synchronous motor and single phase motor, and the speciality and the properties of these motors are different from each other. Hence, this braking method also differs from each other. But we can divide braking into three parts mainly, which are applicable for almost every type of motors. For that, regenerative braking, plugging type braking, and dynamic braking. Here, that regenerative braking. What is that regenerative braking? It takes place whenever the speed of the motor exceeds the synchronous motor. Here it is the main thing. If the speed of the motor is exceed from that synchronous speed, then this regenerative braking use. This braking method is called regenerative braking because here the motor works as a generator and the supply itself it's given a power from load, that is the motors. And the main criteria of regenerative braking is that the rotor has to rotate at a speed higher than the synchronous speed. So only then the motor will act as a generator and the direction of current flow through the circuit and the direction of the torque reverse and the braking takes place. The only disadvantage of this type of braking is that the motor has to run at a super synchronous speed, which may damage the motor mechanically and electrically. But regenerative braking can be done at a subsynchronous speed if a variable frequency source is available. So if it is the variable frequency source is there means then we will have that subsynchronous speed. Then plugging type braking. See, another type of braking is plugging type braking. In this method, the terminals of a supply are reversed. As a result, the generated torque also reverse, which resists the normal rotation of the motor and as a result speed decrease. The thing is, see, as the terminals of a supply reverse so that the generated torque also reverse. which will cause that rotation of the motor and speed will be decreased. This is the plugging type braking. Then during the plugging, external resistance is also introduced into the circuit to limit the flowing current. The main disadvantage of this method is here power is wasted because there is a more power loss over here in that plugging type braking where compared to that regenerative braking. See, this is the type of braking. We can see here it is that separately excited, and this is the series one. Here the voltage is connected with the resistor, then it will connected to that armature, then the external field will connected with separately excited. Here it is that in the coil is in series with that motor as well as that resistance. So here we take that torque versus speed curve. See that motoring is slight decreasing, and plugging will also straight decreasing. Here if you are seeing here the plugging also same as the separately excited, but the motoring speed suddenly decreases. Then dynamic braking. The other method of reversing the direction of the torque and braking the motor is dynamic braking. In this method of braking, the motor which at a running condition is disconnected from the source and connected across the resistance. See, in this dynamic braking, the braking motor which is at a running condition is disconnected from the source. It is disconnected from the source. So source is disconnected and connected across the resistance. When the motor is disconnected, what will happen? When the motor is disconnected from the source, then the rotor keeps rotating due to inertia, and it works as a self-excited generator. When the motor works as a generator, the flow of current and torque gets reversed. See, if the motor is disconnected from the source, then what will happen to the rotor? It will keeps rotating due to inertia, and it works as a self-excited generator. But when the motor works as a generator, the flow of current and the torque gets reversed. That's the main thing we have to denote it here. If the motor works as a generator, the flow of current as well as torque get reversed. That is the main concept over here. Then during that braking, to maintain a steady torque, sectional resistance are cut out one by one. For that braking, we have to maintain the steady state torque. To maintain that steady state torque, the sectional resistance are cut out one by one likewise. This is the dynamic braking diagram. You will see over here. This is the resistance connected across with the motor, and there is a external connection, that is a field coil is connected with the source. Here it is the series one. Here this resistance is connected seriously with that coil, with the coil name is S1 and S2. Here it is a motor, here A1 and A2. You will see the current IA pass through over here, and it will come via S1 and it will go to S2 and it will come up to this negative. Likewise here this positive IA current will go here and it will come up to here. This is the separately excited, and this is the series motor type. That's all. Thank you.